Hi viewers, this is your Sri Ramulu. Energy density in magnetic field. Why the word is taken as energy density? So actually we have to write it is energy stored in magnetic field, we have to write. But energy density is written. Energy density means how much energy will be stored per unit volume, that is called energy density. And here energy in terms of L and I we have to explain, and in terms of B also, not only in terms of B and also in terms of Li. L where L is inductance, I is current. And see here, energy in terms of Li. Consider a circuit with a resistor or inductor L connected to a source of constant EMF epsilon. It is epsilon through a switch S. So it is a diagram. Okay, here the switch S is there. It is R. This is R. It is inductor. It is battery whose capacity or EMF is epsilon. So you have seen big in size battery diagram. So check it. It is switch. It is resistor. It is inductor. Here it is what? It is a battery whose EMF is epsilon. Whose EMF is epsilon. Okay friends, let me go back. On closing the switch, according to Kirchhoff law, Kirchhoff voltage law, there are the two laws are there for Kirchhoff. One is the current law, other one is voltage law. Current law is what? Algebraic sum of current entering and leaving the junction are same. Okay, the sum of the current entering into the junction is equals to sum of the current leaving the junction. Okay, so that is Kirchhoff current law. Voltage law is what? The voltage of battery is equal to the sum of the voltages across the various component is called Kirchhoff voltage law. So that means voltage of battery is equals to voltage here and here their sum. So same thing is given. So voltage of battery, this is epsilon. Voltage across resistor is, voltage formula is current into resistance. It is voltage. And voltage at the inductor is L into di by dt. So it is voltage across the inductor. So actually voltage across the inductor is epsilon. Can be written as epsilon is equals to d phi by dt. It is from Faraday's second law. D phi by dt. Phi value is what? Phi is equals to Li. If you substitute in the place of phi, then what do you write? E epsilon is equals to d into Li by dt. L value is constant, take it outside. Then we can write L into di by dt. Okay friends, how we got that is also given this side. Actually voltage here is epsilon is d phi by dt. Okay, phi value is this one, substitute phi value here, then you can get this one. Multiplying with I on either side, both side, we get both side, here I and here I. So I epsilon I square Li. Okay, so you know the power formula. Power is product of voltage and current. It is power, it is also power, it is also power. Why? Because before multiplying current, it is voltage. If you multiply the current to them, voltage converted into power. Power is equals to voltage into current. So voltage. So I multiplied with I. It is power. Now the rate at which energy supplied by the battery, it is a battery energy. Power means energy, nothing but equal to. So equal to, it is see, to this I am explaining. Sum means plus. Sum of the rate at which joule heat it is. Joule heat is dissipated. Here what? Heat energy will be dissipated in the form of heat. That is how much? This much of. Okay, dissipated in resistor. See here. And the rate at which energy is stored in the inductor. So this is energy stored in the inductor. Okay, what he is saying, whatever power or energy is supplying to this and this at this power is dissipated means wasted in the form of heat, but here power cannot be wasted. At this point power is appeared in the form of this Li di by dt, Li di by dt. Okay. So to this only, so it is in terms of equation and it is in terms of statement only. Next, the above equation is an expression of law of conservation of energy. Yes, energy neither be created nor be destroyed. Okay, so this energy is converted into heat and inductor energy. So heat energy is it cannot available to us, but this available, so it is taken. If um is the magnetic energy, actually energy is denoted by U, so M indicates magnetic energy stored in inductor, then rate at which, rate word can explain to us time. Rate means time. Rate at which magnetic energy stored in inductor is, see, U is the what, um is the energy only. If you multiply with dt, if you divide with the dt and d by dt, it gives rate of energy, magnetic energy. So that means this magnetic energy is depending upon the time. Why it is depending upon the time? So that means this magnetic energy is equal to this energy, right? And so integrate, so for here dt cancel. What do you get finally after getting cancel? Dt dum is equals to Li di only you can get Lid from this. So integrating on both side, integration differentiation cancel, but here this side integration differentiation never cancel. Why? Because certain values are there. So that is why, so here um is equals to this is, yes, isn't it? This is, this way is coming from, it comes from this formula only. First cancel dt on either side. So dum is equals to Li di. Okay, integrate on both sides, then you can get this one. Okay, after integrating, how? Once again, dum is equals to Li di, isn't it? From this dt after cancelling dt. So integrating on either side, integration differentiation cancel. What is there here? Um. And here integration where to where? 0 to I. Why? Because current differentiation is there. So that is why here this is L is taken outside, constant. Okay friends, integration of I is what? Sorry, here I, one more I we have tried in middle here, one more I we have tried. Why? Because I is there, is what? I square by 2, I square by 2, and substituting limit you can get this one, right? Here integration L into I dA actually present. So I, there is no I, so please write I there, and after integrating I with respect to I, we know I square by 2. So that is why here I square by 2 has come. Now, so this is, see, it is energy equation in terms of L and I, so it is over. Next, energy equation in terms of B, that is a magnetic energy density. Inductance of a solenoid. So in the previous classes, if you watch the video, in the previous videos, solenoid, by using the solenoid, so we have derived the value L as a mu naught n square Al. Okay, it is L value. And so from equation 1, see here the equation 1 is there. See, it is equation 1. What is half Li square? Substitute L value in the place of half Li square. So this is, and write this and here multiply and divide with mu naught. Multiplying and dividing with the mu naught, then what happens? Already mu naught is there. If we multiply mu naught square and in the division, mu naught will get. So these three are squares are there. So square terms are written one side. Square terms written in bracket, and outside L is written. A is what? Area. L is length. Area into length gives volume. Okay. Square terms, and write them common square. So like this common square, isn't it? after writing common square. Common square. So we know this value is what? It is a B. We have derived it many times by using Biot-Savart law and by using Ampere's law also to the solenoid. So it is. So B square. So what we got finally? 1 by 2 B square by mu naught into AL. Where AL? AL. So this is called energy. Energy density means if you bring this AL this side, then this is mu m by AL. It is denoted by U. U is called energy density. Energy density. So energy density is what? Simply 1 by 2 B square by mu naught. Okay, 1 by 2 B square by mu naught. So this is called energy density or energy stored per unit volume. How much energy will be stored, magnetic energy per unit volume, it explained like this. And it is in terms of B only. In terms of L and I is half L I square. Already we have calculated half L I square. Okay friends, so this is an important video, so don't skip it. Please watch it till the end. Thank you.